Hi, my name is Michael Rogers.
My name is Caleb Fordhouse, and I'm the engineer for the Weatherbot in our hydroponic system.
Hi, my name is Dakota Johnson.
So the problem that faces every hydroponic system and even farmers is the fact that we have inadequate management of the requirements needed for growth, nutrients, water, light, and aeration. So as we know, these are the biggest problems of any grower, any group. Our solution is that we are going to have robots maintain these so that way there's no room for error and it's constantly being monitored. This is going to be good for at the industrial level. Ultimately, this allows us to optimize all of the requirements for plant growth, yield better plants, more healthy plants, reduce water consumption, and ultimately limit interaction with people.
Hi, my name is Michael Rogers, and this is the BrainBot. Here you can see in the 3D Arduino we have our LED interface with an example of one of the servos that are causing the alarms. Here on the side where we have the circuit, you can see that we have inputs that are simulated by pressure sensors. As the BrainBot receives a certain level of concern, the servo motor turns, activating a horn and a light.
Good morning, everybody. Featured below is the ChemBot. ChemBot has an ocular sensor here to allow the robot to pick up images, i.e. like the sample bottle and the analysis beakers. Here's the analysis tray. Featured here is the vertical arm that will allow the nearby gear motor, allow the sample beaker to be picked up or placed down. Here's a swivel joint that moves this arm, the lower half of the arm, horizontally. And this hand is allowed to open and close, i.e. by a servo motor, to pick up a sample bottle or a glass beaker and place it on the tray. Here is a distance sensor. I'll tell the robot you're X meters away from the nearest object, which will work in conjunction with the rail system so the robot can move around the different sample points throughout the hydroponic system. Here is the code in the wiring diagram. Featured here is the distance sensor, the servo motor that operates the hand, open or shut. Connected here is a 9-volt battery to the gear motor to allow that vertical arm to move up and down.
Hi, my name is Dakota Johnson. This is the Hydrobots. The Hydrobots is mounted to 2 gear trains driven by 2 DC motors. The Hydrobots sensing unit is controlled by a distance sensor. The distance sensor is going to determine if a harvest is actually needed, and if a harvest is needed, the servo motor is going to be responsible for cutting the plants.
My name is Caleb Fordhouse, and I'm the engineer for the Weatherbot in our hydroponic system. And it's got this platform with our UV light on it, the gears that move the light up and down, the motor that controls the gears, and the Arduino that sends signals to the gears when to move. We also have sensors here. We'll detect when O2 levels and CO2 levels are too high and over the limits, and those are done by these sensors over here, and then LEDs will turn on and a signal will be sent to the brain. This is the motor that controls the gears, and the distance sensor that will raise or lower the platform depending on if the light is close enough too far from the plant. So if the plant is growing, the light will move up. If the plant is harvested, the light will move down.
So at this link, as you can see on the screen, will allow you to watch the robots interacting. Our competitors use the word as autonomous, but they only utilize one system that basically does all the monitoring. They don't actually autonomously maintain the system. So that's what we bring to the table, is that we're going to actually fully automate this system. In conclusion, there's lots of things that go into this, but we desperately need something that allows people to grow with real-time data with minimal effort from the people and can produce healthy crops.